Welcome to an intro to volume of a rotational solid. So first things first, what is a rotational solid? So a rotational solid is the solid three-dimensional shape formed by rotating a region, a 2D region, two-dimensional region, about a line serving as an axis, so about an axis. So for an example, we could take, say, the upper half of a circle, right? So we could take the region, which is the unit circle, upper half of the unit circle. And then we could rotate this region about the x-axis. So this is the upper half of the unit circle. If we rotate this about the x-axis, oops, sorry about that. So rotate it about the x-axis. If we just took that entire half of the unit circle and just swept it around about the x-axis, it will wind up forming a sphere. So we'd get the top half and bottom half of the unit circle, but we also would have sort of a sphere coming out. And it's a solid sphere. So not only are we rotating the exterior of the circle, we're also rotating the interior. So it becomes a solid sphere. So we can rotate about the x-axis, the y-axis, any other line. We will focus on vertical and horizontal lines. So the general idea for finding volume is we will essentially slice our shape into very thin slivers. So we can find the volume by slicing the solid into a bunch of very thin pieces. And add up the volumes of those thin pieces. So for example, we could take our, for the sphere, or for the solid sphere, we would have our ball or sphere. And what we could do is we could essentially take a bunch of vertical slices across. So we could take a vertical slice across. And then give it just a very tiny thickness. So essentially we'll just give it a little thickness, and we could make it basically a disc instead of a circle. So we have a very thin disc, which is a cross section, a vertical cross section. So a vertical cross section is a very thin disc with volume sort of that change in x, delta x times pi times the radius squared, right? And the radius itself is a function of x. So this is one thing we could do. We could just take a whole bunch of vertical cross sections, these discs, and add them together. So we will be learning 3 methods. The first method we will use will be as we just saw. So the first method will be using discs. This only works in special cases. This will not always work. And we have 2 other cases that we can always use. So next up, we'll be using what are called washers. These are essentially named after the washers you use with a screw or with a bolt. So our cross sections, instead of looking like discs, will be a disc with a hole in the middle. And then the other one we will use is we will be using shells. Shells are maybe the hardest to conceptualize, but they actually are convenient. Shells, instead of discs, we essentially think of something as an onion. And we take layers after layers of sort of cylinders. So this uses layers of, oops, I need to update my screen. So again, the shells is essentially we use layers of the outside of cylinders. So layers of cylindrical shells. So these will be the 3 methods we will work on. The reason discs will not always work is the sort of discs have to be, the vertical cross sections have to be fully solid. They can't have holes. So for the discs, the vertical cross sections can't have holes. or actually I should just say the cross sections can't have holes. They don't have to be vertical. If they do have holes, then that's when washers appear. So in the next videos, we will start off working with discs, and then we will move into washers, and we will end with the method of using shells.